Hi guys, welcome back. This is Dave with Wyoming Old Iron, and I know this is not a piece of old iron by any stretch of the imagination. There are some components on these microwaves that I want to show you how to test what the norm should be. There rarely are you going to do anything with any of these components, but I wanted you to see how they test on a meter. So we'll start with your high voltage transformer. Now I showed in a previous video checking for power to the transformer, but every so often you'll have a bad transformer. You'll have one that opens up. So we pull one lead. We're gonna check for continuity. Always pull one lead off. If you don't, you'll get false readings. You come in here, try to get the meter in the, there we go. Okay, you notice how 0.3, 0.4 ohms, you shouldn't have zero, but you should have very, very close to 0 ohms on the primary coil of your transformer. Every so often you'll get an open transformer. It's very, very rare, but it does happen. So then I wanted to discuss the fan. You do have a fan that keeps the magnetron cool. Usually if the fan, you got to complain on the fan, it's because it's noisy. But occasionally you'll have one that goes bad. This is a very simple test. You just simply check for 120 volts while the microwave's running. If you have 120 volts to the fan and it's not running, you got a bad fan. That's pretty much it on any microwave. You can check for jammed things in the fan blade, but it's almost always going to be a bad fan. So then we're going to come over here and we'll see if I can get this so you can see it. Okay, so here we have our diode. So this can take two hands. Give me a minute. Okay, so we're still checking our diode here. It's going to take me two hands to take this apart, so give me a minute. We're taking out that Phillips screw where the diode attaches to the body of the microwave. At least we hope we are. That screw's nice and tight. Okay. We'll pull the diode off the capacitor then. Sometimes you can do this, sometimes you can't. Sometimes the diode is hooked to one of the wires. They go to the transformer also. But when it's by itself, you can do this. Okay, so see, the diode is disconnected. So again, you have to have a meter with a fairly high range. Put one of your meter leads in here, and you put one back here, and you'll notice that the meter does not move. Can't read through it. So the diode, again, the diode only lets electricity through one way. So maybe you have to reverse your leads because your meter's using electricity to check the diode. Admittedly, it's 9 volts, but that's what it's using. So you switch your leads around, and this one is too high for my meter to read. You usually have to have a meter that reads what is it, 3 meg or more. Mine doesn't have that capability. We know this diode's good because this unit heats, but that is the steps you go through. You have to have a 9-volt battery. And then the other thing we're going to do is show you how to check the capacitor. This is going to be a little more problematic. Okay, so you notice I've just left the diode disconnected, and the high voltage lead is disconnected. So what we're going to do now is we're going to take our meter, We're going to put it down here where you can see it. Trying to get all this in one screenshot is going to be tough. So you put one lead on one side of the capacitor. There we go. And one lead on the other side. And you notice how the resistance starts climbing. Okay, that capacitor is charging off the battery in my meter. That's what you want to see. If you have an old analog meter, you should see the needle swing up towards 0 and then gradually drop back towards infinite resistance. So if you want to check it again, you have to turn your meter leads around. You have to switch directions, and then you'll see it do the same thing. Assuming I can get in here. See how it's charging again? So that's how you check. Now, if you have a capacitor that does not climb, like that one did, then it is, or if you have a capacitor that doesn't read through at all, you have an open capacitor. Again, very, very rare problem, but possible. And I want to emphasize, you can leave comments, and if you have a question, I mean, I can't diagnose it for you, I'm not there, but okay, so we're wired back up again. So that's how you check all these oddball components that you almost never use. So the last thing on our list is to check for a no heat microwave where you do not have 120 volts to the transformer. And we're going to discuss that in the next video. I do want to mention, however, you saw me monkeying with this capacitor. Always, 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 always takes an insulated screwdriver and insulated pair of pliers. Always ground these things before you mess with them. I once watched a coworker of mine grab an old Amana radar range without grounding it, and it literally threw him up against the wall. So always do that when you're going to be back here working around the capacitor. So thanks for watching. If you're getting something out of this, please hit the subscribe button. And I'll be back and we'll discuss how to check for no heat where there's no power to the transformer.